3.1. This is extrema on an interval. So we're going to start with the extreme value theorem, which says if f of x is continuous on a closed interval AB, then f of x has both a min and a max on that interval. So visually, what that means is, here's our graph, the pink one here, over AB, because the whole function is continuous. There's no undefined points, vertical asymptotes, points of discontinuity, anything like that, gaps or jumps. We have both a minimum and we have a maximum. If you have a function that is not continuous on the AB, and this is not continuous because, remember, these square brackets include the endpoints, all right? Whereas these are open circles, so those points are not included. So we only have a min because you cannot actually reach B. So you just can keep getting closer and closer, but you never actually get to the maximum. And then conversely, if you have a POD in the middle of it, even though the endpoints are defined, it's not continuous. Therefore, we only have a max. There is no min, right? So that's it visually. For it to have a max and a min, you must be continuous on a certain interval. Now, if we look at, and we talked a little bit about this last unit in derivatives, if we look at the derivatives of the extrema, so we can see that we have a max there and a min there. And if I take the derivative, this is the function x cubed minus 3x squared. F prime of x is going to be 3x squared minus 6x. This point, I'm just going to tell you, occurs at 2. X is equal to 2, and this one is at 0. If I do f prime of 0, I end up with 0. If I do f prime of 2, I end up with 2 squared is 4, times 3 is 12. So I end up with 12 minus 12, which is 0. So when we talked a bit about this last unit, maxes and mins, the derivative is equal to 0 because that is the slope of the tangent line, and at those points the tangent line is a horizontal line which has a slope of 0. What we didn't talk about is, what if you have a sharp turn? Sharp turns, the derivative in this case is, or does not exist. It's undefined because it's a sharp turn. Same with this cusp. If this is f of x, call that c. F prime of c does not exist. And I should say y prime does not exist at x equals 0, this point right there. And this, the derivative exists everywhere except at that point. But they're still defined in the original function, and they're still maxes and mins. So that leads to what are called critical numbers. All right, sorry about that. So we're saying relative extrema, or maxes or mins. Relative extrema, which are basically a max or a min, occur when the derivative f prime of x equals 0 or is undefined. And these points are called critical numbers. So for example, if I say, what are the critical numbers, or find, I'm going to call them crits of y is equal to x to the 4 minus 4x squared. First step, take the derivative. So we got 4x cubed minus 8x, set it equal to 0.
He said, oh, my pencil broke after that.
And then solve it. So we're going to take out factor of 4x out. And we get x squared minus 2. So x is equal to 0, which is from that one. This one, if you solve that, x squared minus 2 is equal to 0. Yeah, x squared is equal to 2. So x is equal to plus minus root 2. Don't forget, when you square root something, it's plus or minus. So your critical numbers, or your crits, as I will call them, are 0 and plus minus root 2. So what do you do once you have the critical numbers? Well, that is the next bit, which is called how to find the extrema. Remember, what's an extrema? It's a max or a min on an interval. Okay. So first step is always take the derivative, and find critical numbers. Find your crits. Then evaluate f of x at the crits, and I'm going to put this in pink, and the endpoints. And you'll see why we do that in a sec. And then this isn't really a step, but anyway, we'll talk about it anyway. I write it down. Largest value equals your max, and the smallest equals your min. So here we go. Practice. Find the extrema of f of x is equal to 3x to the fourth minus 4x cubed on the interval -1 to 2. Step 1, find the derivative. So we take the derivative, and I get 12x cubed minus 12x squared. You set the derivative equal to 0. So I factor out a 12x squared, and I'm left with x minus 1. Therefore, your crits are x is equal to 0 for that one, and x is equal to 1. Okay. Second step is evaluate it. Evaluate the critical numbers and the endpoints. So what that means is you plug it into the original. So step 2, we go f of 0, critical number, f of 1, but then you have to evaluate it at the endpoints. F of -1, f of 2. And this is the original function, not the derivative. The derivative is used to find the critical numbers. Those are plugged into the original function to figure out what value it is. So if I put 0 into there, I get 3, 0 to the 4, 0 cubed. That's going to give me 0. F of 1 is going to give me, which is -1. F of -1 it's going to give me 7. And f of 2, what does f of 2 give me? 2 to the 4th minus 4, 2 cubed. You get 16. These are your y values. So you're looking for the highest y value. The largest one, obviously, is this one. So this is your max at this x value and the y value. 2 and 16 is your max. The smallest value is your min. So we have a min at an x value of 1 and a y value of -1. That's your max and min. So, and if you looked at the graph of this function, it looks like this. Um, actually,
I bet you guys probably didn't see
-1. Obviously, my scale is going to be way off, but that's okay. It's 1, and that is 2. So at 2 and 16, that is that point right there. That's our maximum. Our minimum occurs here, which is 1 and -1. And you can see when I put -1 in, I got 7, so the value at that point would be 7. But it is not a maximum. Don't worry about the scale, people. Sorry. And the other thing that I want to point out is this, because it's the largest in the whole function, is called a it's called a absolute or a global max. This, because it's the smallest value in the entire function, is the absolute or global min. And this point right here is a maximum, but it's called a relative max because it is not the highest. Relative max. Okay, let's do one more example. I'll do a trig one. Okay, so here's our function, f of x, 2 sine of x minus cos 2x. Find the extrema on 0 and 2 pi. All right, so first step, take the derivative. Derivative of sine is cosine, so I get 2 cos of x. Now this is a chain rule bit on the second part here. Derivative of cosine is negative sine. So I get negative sine of 2x times the inside derivative, which is 2. So that gives me 2 cos x. These two negatives flip the sign, then move the 2 to the front, and I get that. Now, if you remember math 12, which you probably don't, if I want to solve this equal to 0, I need to make all the x's just a single x. So I'm going to use the double angle identity. Like, I'm not going to expect you to do this in class, but we might as well practice it. Which means sine 2x is equal to 2 sine x cos x, if you remember that. So that gets subbed in, and I get 0 is equal to 2 cos x plus 2 times all of that. 2 sine x cos of x. Which gives me 2 cos x plus 4 sine x cos x. All right. If you want to solve this, factor out a cosine. 2 plus, oh, I have to take out a 2 as well. Let's take out a 2. And then you got 1 plus 2 sine x. So you solve both of these. Where does 2 cos of x equal 0? Well, if you remember the cosine graph, cosine is 0 at 90 and 270. You can do it in rads or degrees. It doesn't actually matter. I'll do it in degrees. 90 and 270. So my critical numbers for that are 90 and 270. For this bit, I get 1 plus 2 sine of x is equal to 0. So that means sine of x is equal to negative a half. Sine, if you remember, is negative in the third and fourth quadrant. Your reference angle is you don't use the negative, and you're going to get 30 degrees. So that's 30, and that's 30. So the rotation to there is x is equal to 180 plus 30 is 210, and that's 330 all the way around to there. So these are your critical numbers. And then to find your maxes and mins, you plug them into the original. So you go f of 90, f of 270, f of 210, f of 330. What are the endpoints? Endpoints is 0 and 2 pi or 0 and 360. F of 0, f of 360. Okay, make sure your calculator is in degree mode, and if you plug those in, f of 0 is negative 1. F of 2 pi is negative 1 or 360. F of 90 is 3. F of 270 is negative 1. This is negative 3 halves, and this is negative 3 halves. So, where's my max? What's the largest value? We have a max at 90. A max at x equals 90, and y is equal to 3. I'm going to show you the graph of this in a sec. And we have a min, the smallest value are these two guys. We have two mins. So we have a min at x is equal to 210 and 330, and the y value is negative 3 over 2 or negative 1.5. So the graph of that function looks like this. It's here. All right. So, actually, let me fix something here. Sorry, people. Okay. So, sorry, that's not what we want. This point right here is 90. This point, which is the min, is at 210. This other min right here is at 330. And this point would be 360. So what you can see is at 90, we get a value of 3. There's your maximum. That is a global max because it's the largest value in the whole function. At 210, we're at negative 3 over 2, these guys. And same with 330. Okay. These are your global mins. And this would be a relative max at 270. That's 270. Right? And it should line up with that one, negative 1. There's 270 right there. All right. Questions for you to practice. Page 167. Numbers 1 to 15 odd. Also 19, 27, 35, 59, 63, and 65. We will do some of this in class tomorrow, but I'll also move on. All right. Take care, everybody.